Welcome back to the Explainer. So let's just dive right into this. Have you ever noticed how talking to some AI models feels, well, kind of like talking to a goldfish? I mean, every single time you start a new chat, they completely forget who you are, what you were just working on, and exactly how you like things done. It's frustrating, right? Well, today, we are exploring the magic behind agent memory, and specifically, we're looking at the fascinating architecture developers are using right now to transform these amnesic chatbots into highly intelligent, stateful AI agents that actually remember you.
Which brings us to a pretty fundamental question to start us off. Why do brilliant AI models have such terrible memories in the first place? Well, the truth is that large language models are, by design, inherently stateless. Outside of their massive initial training data, their reasoning and their awareness are completely confined to the information provided within the context window of a single API call. Once that request is fulfilled, poof, the slate is wiped totally clean.
So the crucial point is we need a systematic way to build that context continuously. The industry calls this context engineering. It's defined as the dynamic assembly and management of information within an LLM's context window to enable stateful, intelligent agents. And guys, this represents a massive paradigm shift. We are moving far, far beyond simple, static prompt engineering, where you just write clever instructions, into dynamically constructing a state-aware payload based on the user, the conversational history, and external data for every single turn of a dialogue. Here is the mental scaffolding for our journey today. We'll start with the stateless AI problem, look at sessions versus long-term memory, compare RAG to agent memory, check out extracting and consolidating data, see how retrieving for inference works, and finally wrap up with trust and privacy. Okay, part one, the stateless AI problem, escaping the amnesia. Now, you might be thinking, hey, can't we just feed the entire chat history into a massive context window? Well, in practice, doing that causes what we call context rot. It's basically like trying to pack everything you own into a single suitcase. It's impossible to find what you actually need in there. Plus, massive prompts drastically increase latency and your API costs, which nobody wants. Think of it like this. Without context engineering, an AI is like a master chef with a great recipe, but absolutely no ingredients. To make a great meal, that chef needs a perfectly curated payload. In the AI's operational loop, it has to constantly fetch the relevant context, prepare it into a prompt, invoke the LLM and any external tools, and then upload any new context right back to persistent storage. This entire cycle has to happen flawlessly to maintain the illusion of continuous memory. Let's move into part two, sessions versus long-term memory. To manage this ever-growing conversational history without hitting those dreaded context rot issues we just talked about, systems rely on two fundamental, deeply interconnected components. And this brilliantly illustrates the core duality here. Think of sessions as your temporary messy workbench used for a current task. It's the unedited, turn-by-turn log of everything said and done right now, including intermediate tool outputs and random scratchpad notes. But memory is the curated, organized filing cabinet for long-term persistence. When a project is done, you don't just shove the whole messy workbench into storage, right? You extract the permanent insights and file them neatly away for the future. Moving right along to section 3, RAG versus agent memory. This brings us to an absolutely crucial distinction in modern AI architecture because we really have to separate external, global data from deeply personal, user-specific context. To really understand the difference, compare a research librarian to a personal assistant. RAG engines act like the librarian. They use static, shared documents to retrieve global world knowledge. The librarian is a total expert on the world, but they don't know anything about you. Memory managers, on the flip side, act like your personal assistant. They handle dynamic, user-specific context. Memory is highly isolated to the individual user and evolves constantly based on your specific interactions. You really need both of these for a fully capable agent. That brings us to section 4, extracting and consolidating memories. This is where the heavy lifting happens, the technical magic pipeline where unstructured conversation actually turns into structured, actionable knowledge. So behind the scenes, this operates through an LLM-driven ETL pipeline. First up, we have ingestion of the raw conversational data from the session. Second is extraction, where we filter out the meaningful signal. Third is consolidation, which is this incredible self-editing phase. And finally, storage in a vector or knowledge graph database. The real beauty here is that modern memory managers automate this entire flow asynchronously in the background.
That means you, the user, never have to sit there and wait for a blocking operation while the AI, quote unquote, saves its memories before it replies to you. Now, the most crucial thing to understand here is that extraction is fundamentally not just summarization. It is the intelligent filtering of meaningful signal from conversational noise based on strict topic definitions. What makes data meaningful is completely defined by the agent's underlying purpose. For a travel agent bot, meaningful data is your preferred airline seat. For a customer support bot, it's your order number. The LLM scans the dialogue, looks for exactly what it's instructed to care about, and completely ignores all the small talk. Once extracted, we hit consolidation. I absolutely love the analogy of a gardener here. The LLM actively tends to the memory garden. It can update an existing memory, which is kind of like pruning a plant. It can create a novel insight, planting a new seed. Or it can delete and invalidate outdated facts, essentially pulling weeds. If you tell your AI you want to travel to New York and later say, actually, scratch that, let's do Paris, the system actively curates and deduplicates the knowledge base so it doesn't hold on to those conflicting facts. Let's see how this builds into Section 5, retrieving memories for inference. So, the memories are successfully extracted and safely stored. Great. But finding the exact right piece of context, exactly when the AI needs it, without blowing up latency, well, that's the next massive hurdle. To avoid pulling up totally useless data, advanced retrieval systems use a blended approach across 3 dimensions. You have relevance, which is semantic conceptual similarity, recency, meaning how fresh or old the memory is, and importance, the baseline significance of the fact. Relying solely on semantic vector similarity is a huge pitfall. I mean, you might pull up a highly relevant but completely outdated memory from 3 years ago. Systems need a blended score of all 3 of these dimensions to surface the perfect piece of context. Once retrieved, where do these memories actually go inside the prompt? Developers use a hybrid strategy for this. Stable, global information like your name or dietary restrictions goes directly into these system instructions. Episodic, transient context is usually injected into the conversation history. And sometimes memories are pulled reactively via tool outputs. But developers have to be super careful here. If you place it incorrectly into the chat log, you risk dialogue injection, where the model mistakenly thinks a retrieved fact was literally just spoken aloud by the user. Let's shift our focus to our final section: trust, provenance, and privacy. When deploying these agents under strict enterprise production constraints, the classic machine learning rule of garbage in, garbage out quickly becomes garbage in means confident garbage out with LLMs. To manage trust, the memory manager meticulously tracks provenance, or the lineage of the data. Bootstrapped data from an internal CRM is high trust, while user input from a chat is slightly lower trust because, let's face it, people change their minds or misremember things. Tool output from external APIs is generally considered pretty brittle. By tracking this origin, the memory manager can logically resolve conflicts. Furthermore, it actually allows memory confidence scores to decay over time, so the AI knows to rely less on stale, uncorroborated information. And of course, in any enterprise setting, privacy is completely non-negotiable. Think of this system as a highly secured corporate archive. Memory is strictly isolated per user via access control lists, meaning my AI assistant will never, ever accidentally leak your proprietary data to me. Furthermore, tools like Model Armor perform rigorous redaction of personally identifiable information before it's ever committed to long-term storage. This is absolutely crucial to prevent what's known as memory poisoning from malicious prompt injections. Now, what's really interesting about this slide is that it brings us to the absolute bleeding edge of agent evolution. Everything we've discussed so far revolves around declarative memory, knowing the what, like facts, figures, and your history. But the frontier? That is procedural memory, knowing the how. This is where agents dynamically update their own operational playbooks, skills, and reasoning paths based on past successes, completely on the fly, without needing any slow, offline fine-tuning. They literally learn how to do their jobs better. Let's bring this all together with the core thesis of our explainer today. RAG makes an agent an expert on facts, while memory makes it an expert on the user. To achieve that magical, true personalization we all expect from next-generation AI, developers are building this incredibly complex asynchronous architectural pipeline behind the scenes to carefully curate your digital profile. Which leaves us with this final, truly fascinating thought. We are entering an era of self-improving agents. If these systems are beginning to build procedural memory, if they can actively remember exactly how to solve complex problems better with every single interaction, What will your AI teach itself tomorrow? Thank you so much for diving into the mechanics of agent memory with me today on The Explainer. Keep learning, keep exploring, and I will catch you in the next one.